My studies have brought me near to a host of biological horrors that many have never dreamed of, much less thought to be real. Perhaps the most notable of these studies have been pathogens: the human vampiric virus, lycanthropic parvovirus, human zombism virus, and others. Each of these contagions resculpts its victim into a grotesque parody of the human form, its medium not of clay, but of bones, sinew, and flesh. Indeed, each virus is a reminder of how delicate our humanity truly is. But individual studies of these viruses, though important, could only ever form an incomplete picture. I knew that to truly understand them, I needed to observe and document their interactions with each other. Now, my valued listener, I will present to you the outcome of an extended study into just what occurs when a victim of lycanthropy is exposed to the virus that leads to zombism. But I will warn you, the results may not be what you expect. Following my observations of specimens singularly afflicted with lycanthropy and of those with zombism, there was still much to be discovered. I do not have the resources I once did, but I knew that if ever these diseases were to become widespread, the possibility of a co-infection with one or more of these cryptic pathogens could lead to even more catastrophic effects than either could achieve on their own. And so I set out to obtain specimens for my research. This was more difficult than it sounds, as my studies of lichens in particular had previously only been the result of deceased individuals. But even now, I do still have some connections. And after some time, a few willing participants were procured. Now, before I proceed, I should clarify that in most cases, the mental state of those individuals affected by LPV quickly deteriorates into something animalistic. There is no cure, nor can there likely be one given the complete remodeling not only of morphological structures, but of cerebral structures as well as a result of the viral infection. Participants in this study were fully informed of their situation, having been exposed to the LPV in some form prior to their recruitment, and were given the choice to proceed. Their contributions to this critical research will be forever remembered. I have spoken at length regarding LPV and HZV in previous recordings. However, a brief survey of these viruses is warranted for this purpose. The lycanthropic parvovirus, or LPV, is a novel strain of zoonotic virus belonging to the family Parvoviridae, having specialized to infect both canines and primates. Like others of its family, LPV is a non-enveloped single-stranded DNA virus, but in contrast to its relatives, LPV does not destroy host cells. Upon entering a cell, the viral DNA immediately integrates itself into the host's chromosomes, and new LPV virions bud from the host cell, leaving it intact though altered. Within a week post-infection, the victim has begun to exhibit the hallmarks of the lycanthropic appearance: widespread hypertrichosis or hair growth, violent behavior, degradation of communication, and the early stages of an agonizing reshaping of bones and soft tissue, the latter of which many do not survive. Those that do are entirely transformed, for lack of a better word, within about 6 weeks. The end result is a human stripped of their higher brain functions, primarily due to a reduction of the prefrontal cortex and hippocampus, with a pronounced mesocephalic snout and a primarily quadrupedal form of locomotion. Notably, and contrary to popular notions, these changes are not tied to any lunar cycle, nor can they be reversed. The human zombism virus, on the other hand, works very, very differently. It belongs to mononegavirales, the same family as those that cause rabies and Ebola, as well as vampirism. Like LPV, it is zoonotic and often transmitted via bites. Unlike LPV, however, it is a negative-stranded RNA virus and utilizes a reverse transcriptase enzyme to produce DNA from its own RNA genome. This new DNA is then absorbed into the host's nucleus and incorporated into its genome via an integrase enzyme. This effectively makes it a provirus, transforming the cell and directing it to synthesize new virions. Of course, HZV's replication strategy is inherently destructive to the host cells, leading to widespread cellular damage, necrosis, and the near-complete breakdown of bodily functions. This is followed by a rapid decline in the host's physiological conditions, with symptoms of aggression, decay, and cognitive decline evident within mere hours. Victims of HZV enter a comatose state approximately 1 to 2 hours following exposure to the virus. In this state, blood flow, respiration, metabolism, and even cardiac function are reduced to nearly nothing. Brain function is also greatly affected, and in fact, the victim frequently appears deceased. Following this phase of infection, the victim reawakens, though the heart has ceased to function entirely. Instead, skeletal muscle performs the role of blood circulation, albeit poorly. As a result, widespread organ failure and tissue necrosis is rapidly evident. Ultimately, these two viruses employ strategies that could almost be considered opposite one another, and this is precisely what makes this case study of particular interest. In the natural world, the concept of co-infection is not only common, at times it is thought to be more common than single infection. In these cases, the two agents of infection often, paradoxically, compete with one another while simultaneously increasing both agents' rate of infection by overwhelming the immune system. In some cases, the presence of two pathogens can be a net positive for both, especially in terms of transmission and progression. This is a concept known as syndemism. But the interactions between HZV and LPV cannot be so neatly categorized. At the cellular and biochemical level, these two viruses engage in a fierce competition for the host's cellular machinery and resources, often negatively impacting their respective pathogenic processes. LPV, aiming to integrate and express its genetic material within the host's DNA, relies on the host's transcription and translation systems for the production of viral proteins necessary for the lichen transformation. This process demands a significant share of the host's nucleotides and energy resources such as ATP, as well as the use for ribosomes for protein synthesis. HZV, on the other hand, replicates its RNA genome by commandeering the host cell's ribosomal machinery to synthesize its viral proteins, a process that similarly exhausts cellular ATP and nucleotide pools. The primary clash appears to arise when both viruses simultaneously attempt to utilize these cellular resources. Eventually, the host cell simply cannot adequately support the replication and protein synthesis demands of both viruses. As I have observed firsthand, this competition can result in impaired replication for both viruses, disrupting the typical progressions of transformation and resulting in grotesquely mixed phenotypic traits. Put simply, this particular co-infection is nothing short of a biological horror. Given my current lack of resources, locating a suitable environment for study proved nearly as difficult as procuring specimens. But with the aid of my assistant, we eventually stumbled upon a decrepit, though large and isolated, warehouse. Observations were conducted over a period of 6 months. Sample size included individuals of roughly the same age, late 20s to mid-30s, and generally considered to have previously been in good health. This study followed 3 phases, each based on the level of LPV infection in the victim and the progression of the associated symptoms. Phase 1, as one might expect, introduced the zombie virus to a host in the very early stages of LPV infection, within 2 to 3 hours following an infected canine's bite. At this point, the LPV has begun to integrate its genetic material into the host DNA, but the spread of the virus has not yet reached every tissue, and the genetic changes that will result in the lichen phenotype have not yet been expressed. At this stage, the host is usually experiencing generic symptoms, such as fever, chills, increased metabolism, etc. The introduction of HZV at this stage disrupts LPV's entire infection process. Due to the zombic virus's ability to aggressively hijack the host's cellular machinery for protein synthesis, it effectively monopolizes the resources necessary for both its replication and the expression of LPV-induced alterations. In short, at earlier stages, the human zombic virus simply outcompetes the lycanthropic parvovirus, halting the eventual lupine transformation. Instead, the death-like coma indicative of an HCV infection will ensue, though generally delayed by several hours, and the host will likely awaken as usual. Interestingly, however, the semi-intelligence that normally lingers for a day or so in a traditional zombie infection is absent when the host has previously been exposed to LPV. Instead, the victim will awaken with immediate and extreme aggression and exhibit increased locomotive speed when compared to standard HCV victims at this stage. Of course, the combination of the arrested heart and gradual systemic necrosis will take its toll as usual, and so within approximately a week, the co-infected morphology is indistinguishable from that of single HCV infection. In the later stages of LPV progression, usually after roughly 6 weeks post-infection, the lichen transformation is largely complete, resulting in the hallmark canine-like appearance, hypertrophic musculature, and the loss of higher mental faculties. Phase 2, then, was the introduction of HCV in victims averaging 5.5 weeks following an infected LPV bite. During this transformative phase, the increased production of growth hormones, epidermal growth factor, fibroblast growth factor, and insulin-like growth factors promote rapid cell division, muscle and bone growth, and enhanced tissue regeneration. Provided the lichen is able to feed consistently, this elevated hormonal cocktail circulates throughout the lichen's body indefinitely. As a result, if the human zombic virus is introduced at this stage, the cellular damage it induces in its host is naturally counteracted. In my findings, this occurs in several ways. First, through its integration into the host's genome, LPV appears to upregulate genes involved in the DNA damage response, which promotes the repair of the multiple forms of genetic damage induced by the zombic virus. We see a clear example of this in the victim's neural tissues. You see, generally speaking, HCV exhibits cytopathic effects on these tissues, leading to neuronal cell death. It also affects these tissues indirectly, inducing a chronic inflammatory response, the latter of which contributes to further neural damage and dysfunction. HCV's replication within neurons also disrupts normal cellular functions, leading to apoptosis. The inflammatory response exacerbates this damage, potentially leading to demyelination and the loss of neural connectivity. However, notably, the previously mentioned elevated levels of growth factors in the LPV host actually stimulate neurogenesis and the repair of both neurons and glial cells, in a limited way counteracting the mental degradation caused by HCV. Similar enhanced repair mechanisms can be observed in multiple tissue types, which serves to slow the necrotic damage induced by HCV at the systemic level. Notably, no cardiac arrest occurs in victims at this stage, nor does any kind of coma, a hallmark of traditional HCV infection. However, it should be noted that while the effects of the lichen virus do work to counteract many symptoms normally brought on by the zombic virus, HCV infection is not so easily defeated. The success of a lichen fending off the HCV appears to depend on multiple factors, beginning with viral load. In short, it appears that an exceptionally high concentration of HCV can overwhelm the host's cellular machinery and immune response, outpacing the regenerative processes induced by LPV altogether. And though additional long-term studies will be necessary to confirm, it seems likely that over time, the continuous battle between regeneration and degeneration will deplete the host's resources, allowing HCV to gain the upper hand, so to speak. This possibility isn't unique to this phase, however, and so we will return to this concept momentarily. Physically, late-stage victims of this particular co-infection also exhibit grotesque external symptoms. My observations consistently demonstrated that the covering of thick body hair brought on by hypertrichosis is interrupted by patches of epidermal necrosis and inflammation brought on by the HCV. Depending on the severity of HCV infection, one may also observe regions of highly decayed flesh, even exposed bone, but even these sites may exhibit reticulated scar tissue as the enhanced healing rate brought on by LPV attempts to overcome the damage. I have also observed that the enhanced lichen sensory abilities are often moderately reduced in these late-stage victims. Interestingly, however, olfaction may actually be improved, a noted side effect of HCV's proliferation of olfactory receptors and limbic neurons. Ultimately, though the LPV attempts to resist and counteract any new infection, even one so aggressively damaging as HCV, prognosis for the late-stage host is highly dependent on initial overall health and viral load. In my testing of the total sample size were able to resist the long-term effects of HCV effectively, exhibiting only moderate symptoms before returning to near baseline lichen health levels. In individuals, however, symptoms were more pronounced, and limited tissue necrosis, reduced cognition, and sensory impairment persisted for the duration of the study. Long-term observations will be required to accurately determine the extent of this variation, especially in relation to longevity. But while the preceding 2 phases provided invaluable data, neither could prepare me for the horrors that awaited me in the 3rd. At this point, I must admit the psychological toll of this testing was beginning to wear not only on me, but also my assistant. These are cruel diseases, and frankly, after watching person after person descend into this madness and pain, continuing becomes a matter of pure will. Let's see. In any case, for this 3rd phase of testing, we were able to obtain 3 additional specimens, each in the same age range as the others had been, and between 15 to 20 days post-LPV infection. This is a period of the most profound changes in the lichen morphology. Bones are elongated, the posture becomes stooped, and the victims are in clear and near constant discomfort as nearly every tissue in their body is being actively reshaped. It is this stage that, upon introduction of the human zombic virus, results in the highest level of variability. A moderate dose of HZV was given to each specimen. Approximately 4 hours later, 2 of the 3 specimens began to exhibit hallmark signs of infection, such as a spike in heart rate and the onset of a high fever. Shortly after this, each succumbed to the typical zombic coma, wherein the heart rate slows and eventually stops, while the fever continues, escalating to the point of damaged brain function. The 3rd specimen exhibited a similar initial reaction, but did not fall unconscious, and in fact appeared to recover fully within 3 hours. Of the 2 that did enter the coma, 1 awakened within 2 hours, much shorter than the typical 4 to 6. And though his heart rate slowed significantly, interestingly, it never fully arrested. Sadly, the other specimen did not reawaken at all, and expired within approximately 57 minutes after falling unconscious. An autopsy revealed signs of severe metabolic exhaustion, with decreased ATP production and elevated markers of oxidative stress. Ultimately, the struggle to accommodate and fight the dual viral infections likely contributed to an overall weakened condition and impaired regenerative capabilities. In terms of immune response, this unfortunate outcome is not surprising, as upon co-infection, the immune system faces 2 vastly different pathogens. As previously established, LPV subtly alters host cellular functions without eliciting direct cytolysis, while HZV's replication mechanism is characterized by widespread cell death. In any case, it is clear that the body struggles greatly to cope with these infections, and to be honest, it is astounding that any individuals survive at all. Those that do show just how highly variable and volatile the nature of a mid-stage co-infection of this sort can be. Over the following days, the remaining specimens, A and B as I will call them, exhibited numerous additional and increasingly bizarre symptoms. Externally, specimen A in particular began to exhibit striking asymmetry, with much of the right side of the body showing the enhanced muscular development characteristic of LPV-induced anabolism, while the majority of the left side displayed muscular wasting and necrotic lesions, indicative of HZV's catabolic and cytopathic effects. At the cellular level, this asymmetry appears to be the result of localized viral dominance, wherein LPV's integration into the host DNA in some bodily regions promotes protein synthesis and muscle fiber hypertrophy. HZV's replication in other regions leads to increased proteolysis and apoptosis of muscle cells. Additionally, the skin and fur exhibited abnormalities ranging from robust fur growth to ulcerated necrotic patches. Specimen B, which did not enter the zombic coma, exhibited a far less pronounced juxtaposition. However, signs of severe cognitive decline became rapidly apparent. In typical lichens, this transformative stage is marked by increased aggression and an apparent loss of higher reasoning, largely resulting from the reduction of the prefrontal cortex. However, despite this, they often remain cunning, showing signs of lower intelligence, particularly in their hunting and evasion strategies. Specimen B's behavior, however, degraded further. He often flung himself against the walls of his containment, even to the point of personal injury, and regarded us with vicious, mindless intensity. In truth, it was a tragic thing to watch, and it resurfaced memories of finding Allison's body, so mangled and broken. In the specimen before us, the HZV began to degrade the senses of sight and hearing, and the characteristic lichen responsiveness was lost almost entirely, with the notable exception of smell. Interestingly, the eyes of specimen B exhibited a striking heterogeneity. The left eye retained the enhanced clarity typical of lichen transformation, while the right eye exhibited cloudiness and reduced responsiveness, a sign of HZV-induced cataract formation. Within 24 hours following exposure to HZV, both specimens exhibited what at first appeared to be improved reflexes. I attributed this to the combined regenerative effects of the viruses, particularly to the increased muscular innervation caused by HZV. However, the specimens soon exhibited overly heightened sensitivity to stimuli, to the point that gentle prodding seemed to induce visceral reactions, as well as sporadic muscle spasms throughout the body. It became apparent that what we were seeing was, in essence, a zombified brain barely in control of a hulk of muscle and teeth. Particularly in specimen A, heart rate never returned to pre-coma baseline levels, and blood samples indicated increasingly viscous consistency due to raised iron and bile levels, which in turn reduced overall circulation. This led inevitably to a continual spread of necrosis in multiple tissues, particularly of the muscle and surface dermal layers in the extremities. However, because the heart continues to beat, unlike in single HZV infections, contractions of the skeletal muscles are not critical to circulation. In one way, this is good, because the muscular spasms in co-infected individuals appear random, uncoordinated, and somewhat violent, a far cry from the systemic, almost rhythmic pulsations seen in single infected. Specimen B exhibited far fewer spasmodic contractions, especially as the lichen transformation progressed. In this state of partial transformation, however, caught in limbo between two warring pathogens and in nearly constant distress, both specimens tragically died within 2 weeks following co-infection. Indeed, prognosis for organisms affected by this particular co-infection is dire, to say the least. Even on their own, each strain greatly increases morbidity, LPV due to the immense physiological toll such a transformation takes on its host, even if they survive past that point, and HZV due to its inherently destructive nature. Still, a traditional LPV victim may live for years in the lycanthropic state. However, with the exception of the late-stage victims, all of the specimens I observed were deceased within 3 months. Interestingly though, even for those that did not survive, death was preceded by a general period wherein the victims appeared to stabilize, perhaps having reached a kind of equilibrium between LPV's regenerative effects and the degenerative effects of HZV. However, it quickly became apparent that this continuous tension, compounded by the energy and resource demands of fighting off 2 viral infections, would simply deplete the host's physiological reserves. One aspect of my work that will require more in-depth studies is that of transmission. Given our small sample size, which only included infected specimens, I was unable to determine whether the rate of infection increased as a result of co-infection, particularly through the preferred transmission vector of both contagions, a bite. Of course, a co-infected individual would likely exhibit unpredictable transmission characteristics. For example, in the wild, the increased aggression and physical capabilities of a kind of lichen-zombie hybrid may make them more effective at spreading both infections. However, the clear and visible signs of decay and the erratic behavior associated with this co-infection could make potential victims more cautious and less likely to engage with the host, potentially reducing transmission opportunities. It also appears that the loss of the cunning lower intelligence in the lichen brain makes them far less efficient hunters and therefore less likely to be able to spread either disease. By the time my study concluded, my perspective on these viruses and their effects on a host were forever altered. Beyond the biological effects of each individual strain, the complete usurpation of the victim's humanity is staggering. For now, their prevalence in the wild is minimal, especially in humans, and outbreaks have been swiftly contained. But what will happen if these infections begin to overlap more frequently? I fear the result is much greater difficulty in containment. A zombified lichen, after all, a creature whose outward appearance is a patchwork of symptoms, possesses only a singular, mindless directive: to consume at any cost. When it comes to exploration, to discovery, science gives us a framework to understand the world around us. And for anyone who seeks to illuminate those dark corners of their own knowledge, there is perhaps no better place than Brilliant.org, a free and easy way to learn mathematics, data science, computer science, and much more. What sets Brilliant apart for me is that instead of watching dry online lectures, each of these sometimes intimidating topics is broken down into interactive, engaging lessons that I can complete anywhere, phone, tablet, or computer, and in as little as 15 minutes a day. And Brilliant has thousands of lessons, with new ones added every month, from foundational math to advanced physics. But don't worry, whatever your skill level, Brilliant customizes the content to fit your needs, and these lessons let you explore concepts at your own pace, while still providing a guided challenge. One course I thought would be interesting was LLMs, and boy was I right. Large language models are kind of all the rage right now, but actually understanding how they work, from n-gram models to predictive temperatures, and in such a dynamic way, is so much more satisfying than just thinking they're magic. So if you'd like to expand your knowledge and have fun doing it, you can check out any of Brilliant's courses for free for 30 days. Even better, the first 200 people to visit brilliant.org/thoughtpotato will get 20% off the annual premium subscription. The link is also in the description, so don't wait. Get started with Brilliant today. This video was made possible by Brilliant and by viewers like you. Thank you. And remember, you matter.